Okay, welcome back. Last objective, going to apply the compound interest formula. And when we use this formula is when we have a savings account or saving instrument or investment instrument where earnings are reinvested and use compound interest. The term compound interest, it refers to the interest earned as well as the accumulated value of the amount. Okay, we can calculate the compound interest using a compound interest formula, which is an exponential function. And it uses the variables time, t, the principal, p, the annual percentage rate, r, and the number of compoundings per year. So it looks like A of t equals P1 plus R over N to the NT power. Now, N is going to be different depending on how many compoundings you have per year. We compound annually, N is equal to 1. Semi-annually is 2. Quarterly would be 4. Monthly is 12. Daily would be 365. Now, most banks pay interest monthly, but the compounding interval depends on the bank. And you want to get an account that compounds more often because the interest earned increases as N increases. Now, this is interesting about N is that this expression, we have 1 plus 1 over N. This value approaches a number used very frequently in math, and it gets its own name, and we call it E. Now, this E value is an irrational number. It's about 2.718, and we're going to actually use this when we're in a different section when we're doing some modeling and applications for exponential functions. Let's look at the compounded continuously formula. This is where you compound continuously, and we're going to actually use this number E in our formula. It is A of t equals P times E raised to the RT, where your P is the principal, your R your interest rate, and your T is time in years. Let's look at the next example together. This should be actually example 9. If we have $5,000 that are being invested in a high yield savings account. Now, interest rates have been going up, so I was able to find a high yield savings account as high as 3.11%. And let's say we're investing for about 10 years. Okay, calculate the amount if the bank, in the bank, if interest is compounded monthly. So what that means monthly means that N is going to be 12. Let's determine then which formula we're going to use. Compounded monthly means we're going to use the formula A of t equals P 1 plus R over N to the NT. The principal is the initial amount that's invested, 5,000. Our R is 3.11%. We need to change this as a decimal, so it's going to be 0.0311. T years is 10. I think we have all the variables identified. So then A of 10 is $5,000, 1 plus 0.0311 divided by N, which is 12, to raise to the power 12 times 10. I'm going to pull out our calculator for this. Let's pull that out and calculate this together. Okay, so if we go to our main screen, we have 5,000. 1 plus 0.0311 divided by 12. I'm going to raise that to 12 times 10. And it says we get $6,821.20. So it looks like we made we accrued some interest, about $1,800. 6821.20. Okay, let's now calculate the amount if the interest is compounded continuously. Now it says continuously, so we don't actually have an end value for this. We're going to use the compounded continuously formula. A of t equals P E raised to the RT. And all the values are the same. So we have A of 10 equals 5,000 E to 0.0311 times 10. Okay, let's put that in our calculator. Okay, we have 5,000. Your E buttons is above your LN button. We get what was it again? 0.0311 times 10. 6823.95 cents. It's a little more because, right, compounding continuously is a lot more often than monthly. Okay, so it's about 6823.95 cents. Okay, so that's it for exponential functions. Okay, I hope you found this helpful. Of course, you can reach out to me or your professors if you have questions on this section.